Hello everyone. Today we are going to see about CPU scheduling algorithms. The process which are arriving in the queue will be allocated to the CPU using different techniques. Today we are going to see about FCFS scheduling algorithm. FCFS stands for first come first serve scheduling. This is the basic simplest scheduling algorithm technique. In this, the process will be allocated to the CPU on the basis of FIFO queue. What is the FIFO queue? In this FIFO queue, the NQ process will be done at the tail of the queue and the DQ process will be done at the head of the queue. The process which arrives first will be put into the queue and the process which arrives next will be inserted at the back end of the queue. And whenever the CPU is free, the process which is at the head will be taken out from the queue and it will be allocated to the CPU. After completion of the first process, then the process which is next in the queue at the top of the head will be allocated to the CPU. This is the scheduling technique which is used for FCFS scheduling. Let's see an example for this. In this, the example, the inputs given are the number of process along with its burst time and the arrival time. And the output we are going to find for this FCFS scheduling is, first one is the Gantt chart. Next, we have to find its turnaround time. Third, we have to find its waiting time. In this, Gantt chart is nothing but the bar chart which illustrates the sequence of process execution along with its starting and completion time. And waiting time is the total amount of time spent by a process in its waiting or ready queue. And the turnaround time is the total amount of time spent in the queue along with its completion time. Then the waiting time and turnaround time is found using the formulas. It can be found using two methodologies. In first method, first we have to find the waiting time, and using the waiting time we will be finding the turnaround time. The formula which is used is waiting time equal to starting time minus arrival time of the process. And with that waiting time, for finding the turnaround time, we will be adding burst time along with this waiting time. In another method, we can do the same, but the thing is that first we have to find the turnaround time, and using the turnaround time, we will be finding the waiting time. The formula used is turnaround time equal to completion time minus arrival time, waiting time equal to turnaround time minus burst time. In this, the next coming example is done using first method. I am using the formula waiting time equal to starting time minus arrival time, and turnaround time. For that waiting time, I will be adding the burst time and I will find the turnaround time. So method 1 is the formula I am going to use in today's example. Okay, let's see about it. So this is the process P1, P2 and P3. All the three processes arrives at the time sequence of 0 milliseconds. Then the burst time is given. Burst time for process P1 is 24 and process P2 is 3 and process P3 is 3. First one, we are going to find its Gantt chart. Let's consider the process arrives in the sequence of P1, P2 and P3. So first process arriving is P1. It will be allocated to the CPU, right? The process arrives at 0 and it's directly allocated to the CPU. So from 0 till the completion of burst time, 0 to 24, the CPU is occupied by the process P1. It is indicated in the Gantt chart first. Then after completion of the process P1, next P2 is allocated to the CPU. The burst time of P2 is 3. So we have to add that 3 along with the 24. So 24 is the starting time of process P2 and its burst time is 3. So 24 plus 3, 27 is the completion time of the process P2. Then process P3 is arriving. P3 is allocated to the CPU and the process P3 starting time is 27 and its burst time is 3. So 27 plus 3 equal to 30. 30 is the completion time of process P3. Using this Gantt chart, we are going to find the waiting time and turnaround time of the process for this example. Waiting time formula used here is waiting time equal to starting time minus arrival time. As said before, the arrival time of all the three processes are 0. For process P1, the starting time is 0 minus arrival time of P1 is 0. 0 minus 0 equal to waiting time is 0. Then for process P2, the starting time of P2 is 24 minus arrival time is 0. 24 minus 0 is 24. Then for process P3, the starting time is 27 minus its arrival time is 0. So 27 minus 0, its waiting time is 27. The average waiting time is calculated by finding the average of process P1, P2 and P3's waiting time. So 0 plus 24 plus 27 divided by 3. Its total sum is 51. So 51 by 3, it is 17. So 17 milliseconds is the average waiting time for this given example. Then using this waiting time, we are going to find the turnaround time of each process. Turnaround time is the waiting time plus burst time. Using that formula, we are going to find it. For process P1, the waiting time is 0. Its burst time is 24. So 0 plus 24 equal to 24. It is the turnaround time for process P1. Then for process P2, same formula, waiting time plus burst time. Waiting time of process P2 is 24 plus its burst time is 3. So total 27 is the turnaround time of P2. Then for P3, waiting time of P3 is 27 plus its burst time is 3. So 27 plus 3 equal to 30. It's the turnaround time for P3. For finding the average turnaround time for P1, P2 and P3, we have to sum all these process turnaround time and find its average. So 24 plus 27 plus 30 divided by 3 equal to 81 by 3. Then the division value is 27. So 27 milliseconds is the average turnaround time for this process scheduling using FCFS scheduling algorithm. Okay, let's see another example regarding if the arrival time varies. In this, the process P1, P2 and P3 are having same arrival time. If the arrival time varies, then the value which we are subtracting will be varying. So let's see another example for different arrival time for different processes. Okay, this is nothing but the calculation of waiting and turnaround time for the previous example.